Information retrieval is a whole lot of science, and what we have in Postgres is a fraction of this science, but it still is quite big. We have a lot of different tools, and here we will discuss maybe just three most fundamental and most important, most vital parts of our tools in Postgres. First, to bring up text search, we need data types to represent our information and our queries, our documents and our user text search queries. Then we have a function to compute relevance of our documents, and we won't discuss a relevance function in details. And finally, we have indexes to make search fast. And this is a part of Postgres which we'll focus more, but still we can discuss every single text search access method that is available to Postgres user right now. Okay, first thing you want to know about text search in Postgres is a TS vector. This is a data type to contain text search information about your document. Here we create TS vector from a sentence brown cat sees other cat. We can see that TS vector constructed from this text contains information that this text contains brown at position 1, this text contains cat at position 2 and 5, and contains normalized verb see at position 3. Word other was omitted as not important as stop word, and position information is needed to some relevance calculation functions to search not just for green and for apples, but for green apples nearby. Then we have a TS query. This is a data type which represents user input, user information need, some interpretation of user information need. Here we create a TS query from text brown and cat and not dog. This query is normalized to brown and cat and not dog. And we have a operator match between TS vector and TS query. Here we can see that text brown cat sees other cat is relevant to query brown and cat and not dog. But if we change the last word to brown cat sees other dog, this text is no more relevant to brown and cat and not dog, because now it contains dog. There are many different predicates available to TS query, and I recommend you to look through the documentation to see how you can form text search query. We have a few operators to combine, concatenate many TS vectors. During concatenation of TS vectors, you can also use so-called labeling. So some parts of your TS vector can be taken from a title of your document, some words can be taken from abstract part of a document, some words can be taken from other specific areas of a document, and you can label these sources of terms to search only by titles or only in abstracts. And in Postgres you can have 4 labels, A, B, C, and D inside a TS vector. You also can concatenate through AND or through OR TS queries and check whether TS query is relevant to some TS vector. And one of important functions here is TS debug. this function allows you to see how your text was translated into TS vector. Here we see that word hello was transformed by English stemmer, and word привет was translated by Russian stemmer, which understands that this is Cyrillic letters and should be taken from Russian dictionary. Composition of dictionaries inside your cluster and everything that is responsible for converting from text to TS vector and TS query is called full text search configuration. And this is a part of configuration I recommend you to inspect in documents. Now let's talk about how to make search fast. So we now already, while we have data types for text search, technically this is enough for search. But how to make it fast? Obviously, we need to use access methods.